So the last question of our GP and AP progressions okay, so this last question reads express 3.333333 as a fraction. So I'm sure everyone remembers this in term 1. We used to say that this question used to go like this: express we say that express the number below as a fraction, as a in form of a over b, where a and b are integers and have no common denominators, have no common factor. Yeah, it's actually the same way we're expressing this in the form of a over b, but the only difference now is that is that we are not using that formula we used to use. We're going to use the formula for sum of the infinity. As I said, this number is read 3.3333 to infinity. So now, how are we going to do this? We're going to use the sum to infinity. This is the symbol for sum to infinity, which is equal to first term all over 1. In fact, yeah, 1 minus ri, 1 minus r. That's how it should be. Why is it 1 minus r and not r minus 1? It is because we can never have we cannot accept r being bigger than 1 for this process to work. We're saying r should go to infinity, meaning should reach to 0, should finish. Okay, in this process we have the number 0.333 going to infinity. So now, how are we going to plug this on the sum to infinity? That's what you should be asking people. Okay, now in this case we're going to make up we're going to split this into terms saying that this one has a first term, which is 0.3. That's the first term. Second term is going to be, we're going to say plus 0.03. That's how it's going. If you add all this, you're going to find yourself back there plus 0.003. That's how it should be, just going plus 0.0003. So when you add all these things, you're going to find yourself back to there. So those are our terms that have come out of that number. So now, meaning we'll find our first term, our a, which is 0.3. Okay, and our common ratio is which we know that is always 0.03 all over what? All over 0.3. Okay, so this one, if we multiply, say let's multiply by 100 so that we can make a number. So by 100 we're going to have 3 all over 30, 3 over 30, and that one can lead us to either 10, or we can say it's going to be 0.1, right? It's going to be 0.1. Okay, so having what we have there, so we have the common ratio and we have the first term, so we can now plug everything there. So we have sum to infinity is equal to our common ratio. Our first term is 0.3, and our sum to infinity, 1 minus 0.1 as our common difference, as our common ratio. So in this case, let's first work with 1 minus 0.1. So in this case, we can say 1.0 minus 0.1. How does it go? So we're minusing. We're going to say, we're going to borrow here. This is going to be 0, and this is going to be 1, and this is going to be 9. So it's going to be, so we're going to have sum to infinity is equal to 0.3 over 0.9. And to just turn it into a fraction, a real fraction, since there are decimals there, to remove the decimals, since they're all to the one decimal place, I can multiply by 10 and by 10 to just make them what? 3 over 9. This can change to what? To 1 over 3. So there you have it. So when you do 1 divided by 3, you're going to have the 0.3333333 up to the last. So yeah, hence we have made it a fraction.